So today I'm going to review this Owon digital multimeter. Honestly, it's in the box. Apparently it is anyway. So let's see what we've got. Got a incorrect power cable, but AEC, nothing special there. We've got a USB cable. Got some croc clips. Got some probes. There's the multimeter. And you also have a manual. Let's have a quick look at the manual first. There it is. Here's the specs. Let's look at these though. Actually, the specs don't look too bad. 0.1%, 0.05%, plus 10 counts, 5 counts. Whoa, that's a lot of counts actually. But okay. True MS, 1%. That's actually not too bad. I mean, 30 counts though. 30 counts. Percentages look good, but the counts, obviously the main initial tolerance is a bit off, but yeah, okay. It's much what you'd expect, I think. Adjustable threshold continuity mode, right, diode test 3 volts, resistance up to 50 meg, 10 amp current, up to 750 volts AC, 1000 volts DC, we can check that. Capacitance up to 50 millifarad, and it's got recording as well apparently. And on the back we've got some more details there. Really been any time, I suppose. So I'm putting this thing through its paces on my calibration equipment. So I've got my multi-purpose calibrator, I'll chuck it on that. I've also got my standards, like my capacitance standards and things like that, we'll check it on those too. Cables, PVC cables, quite plasticized. Standard points, nothing particularly special, not particularly sharp. I mean, they're sharp-ish, it's not too bad. Yeah, these are the standard cables. Nothing particularly special about those. Standard clips. Yeah, nothing special about those either, just standard off-the-shelf clips. I mean, these are all nice things to have, but these aren't super high quality ones or anything like that, just basic ones. So there's the unit. Screen peel possibility, we may do a screen peel. Maybe. If you put enough comments down below, I'll do a screen peel. Honest. Anyway, rubber foot on the back there, plastic foot on the front. Yeah. That ain't gonna work. It's not heavy enough to allow you to push the buttons. These ones, you can push that one, barely push that one, can't really push that one, can't push that, can't push. Yep, if you want to push any of those buttons at all, you will have to hold it and push the button. You can't just push it, because it just falls over. Back of the unit we got a USB port and a standard mains power port here. I might do a teardown this thing later on too. But put this thing to its paces, we'll check it on the continuity mode and we'll check the diode test function out and things like that, and we'll see how good it actually is. Is it worth the money? This was sent to me at no cost by Banggood, so I didn't pay for this. This is for the purpose of review. So for me, it's a great price. For you, I don't know, you have to buy one. Now I do lots of these kinds of review videos. People which watch my channel already will know that, but if you're new here, I review test meters and things like this and repair bits of test equipment, things like that. So if you are new here, make sure you subscribe down there, click the bell icon, you know, I can push the button to remind you. Click subscribe right now, quick, before you forget. I put this stuff through its paces on test equipment, so I've got a calibrator over there in the other side of the room, costs about $10,000. I'm going to put this on it, why not? And I've got various standards and things as well, like, you know, the standards themselves, each one of them will cost more than this costs. So yeah, I've got some gear to test this thing out on. Right, let's plug this thing into power. Well, plug the power cable in at least. I think I'll do a teardown on this later on as well. We'll see how we go. It looks like it's going to be easy to get into. Yep, it's crosshair screws, so we'll pull it apart and have a look at it later as well. So, let's turn the power on. With it turned off, I'm seeing no power draw whatsoever. Absolutely none. There you go, it's booting up. And you see those lines across the screen, that mural pattern? I don't actually see that, it's purely because of the shutter on the camera versus the screen on here. Put on different positions, there you go, like there it's completely gone. Alright, so that's not actually really there. So this is drawing 1.3 watts at 240 volts. Nice enough display. Okay, well, let's plug some probes in and give it a try out. So obviously the first mode it drops into is volts DC. Whether it remembers the last one or not, I don't know. Let's go to different modes. This is saying resistance. Continuity tester. Okay, beepers on, threshold 50 ohms. It's quite a nice little display. It's a bit slow. Not too bad, but it's slightly on the slow side. Let's improve the test on this. Let's plug it in Johnston's DMM continuity tester. This thing is basically a switch, a timed switch, and it will create pulses which are used to test diode mode functions. So right now it's doing a 5 millisecond pulse with a 250 millisecond gap in between the pulses. So let's increase this pulse time because it's not seeing it right now. The fastest meter I've got will do it on 1 millisecond. Well, less than that. You can go right down to minimum on this thing and it'll still see it. So now we're just starting to see an occasional flick up here at 72 milliseconds. Here we go. 96. So 100 milliseconds is close to the minimum. Yeah, it's about 110 milliseconds. Like I said, it's a little bit on the slow side. Well, that's as slow as this can go, 250 milliseconds. And you can see it's not reliable for that. It's a bit slow. So I suppose I should actually go through what functions this thing's actually got before I go into detail about the actual how well it works. I sort of jumped ahead a bit there, got excited. So we got DC volts, so just like AC volts is also on the same one. There we go, you push it twice to switch between them. Okay, that's nice. Optimization of controls. Auto ranging, got manual ranging on there. We can do voltage and millivolts on the same button as well. And high speed or low speed. I guess it's got some kind of smoothing in there. And voltage and millivolts as well, the same function as well. That's a nice and simple. Current, DC, AC I'm guessing as well. Will be if I do that, yep. And it's got the same kind of functions as the other one. Relative mode, that's nice. It had it on there too, didn't it? Yes it did. It's nice, it also tells you what range it's currently in as well. So this button here, as you found with Diode Mode, so you'll start with resistance, again auto ranging, relative mode. It's nice to got relative function across all of these. Beeper, and diode test. So diode test, I didn't check the speed of that one, sometimes that actually matters, and whether or not it actually does beep during diode test. Let's have a look. Sometimes it do. Diode test is fast. Continuity mode is slow. Diode test is fast. Let's plug the tester back in again. I wasn't expecting that. Let's see what we get this time. Now don't forget, last time we had 100 milliseconds was the time. Now it's about 20 milliseconds. Yeah, just about 20 milliseconds. 25 slightly better. Significant difference between those two modes. So if you want to do continuity testing and want it to be fast, use diode mode, because that makes total sense. So other modes, you've got capacitance mode here. Also got relative mode, that's nice. Not many meters actually have relative mode on capacitance, that's quite good. Frequency mode, again you've got relative on that as well. Temperature, single mode, yep. So these are the types of thermocouples you can use, or probes. Display temperature, display measure, display all. Okay, so it's got measurement down here, and converted temperature. Celsius Fahrenheit, okay, that's all nice. Unstop, so you can pause it and re-trigger, automatic triggering, okay. Math functions. Let's go to DC volts. What math functions got on here? So we've got min-max display on. Here we go, so you can display min-max values here. What other options have we got? Just on, off, or dB, dBm. So you show dB instead of volts. Well, that all seems nice enough. I guess it does different things on different ranges. Let's do math on resistance. What we got here? Min-max again as well. Okay, so it's probably limited functions. We got dual mode. Let's see what dual can do. How do we do dual mode? Don't know how to do dual. I'll have to figure that one out. Sometimes you can only do that on certain things. Don't know, I can't seem to see what that does. Anyway, let's figure that out maybe. Utility, let's see what we've got in here. Languages. It's like you have to keep pushing it to scroll through each one. Back to English again, backlight 100%. That's fine for now. Next, serial communication, because it's got USB, but it's effectively a serial port. It doesn't actually have a serial port on it, so I'm a bit confused by that part. Clock, you can set the time if you really think you need to. Default settings. Okay. And here's the version information in case you care about that. Right, let's do some more testing. So right here I have Ian Johnston's PDVS2 Mini. This is a precision reference. Adjustable from 0 volts to 10 volts, if you haven't seen this before. He sells these. If you want one of these, you can actually buy them. They aren't cheap, but they're invaluable if you're doing any kind of testing like this. Set to 0 volts. We are indeed getting 0 volts. So let's do millivolts first, shall we? Let's do 1 millivolt. It's actually not bad. Now we actually have function volts, function millivolts. So there we go. That's actually surprisingly good. That is actually surprisingly good. I'm actually genuinely surprised. I wasn't expecting to have this resolution. Okay. So 100 millivolts. There we go. It is being a little bit slow. Let's try changing to a fast speed. And change the voltages now. Okay. Obviously you get better readings with lower speed because it will give you a more accurate reading. Eliminating some noise, that kind of stuff. That's usually what I do. Some kind of averaging. Okay, that's fine. So let's go back to volts. So there's a slight discrepancy there, a couple of counts, maybe one count. It's pretty close. 2 millivolts. Now this is actually supposed to be a 5500 count, right? So I should be able to do half a volt. Getting like 2 counts out here, and I should still be able to get half of, well, 500 millivolts on this screen. And we can. So this one, the reading's slightly high. And this one is reading slightly low. Not much. Not bad though. So let's keep going up. Let's do 1 volt. I'm going to put this on my proper calibrator as well and check this in more detail, but this is just the preliminary look at it to see how we're actually getting. So 1 volt here, 2 counts down. Alright. 2 volts. 2 counts down. I mean 2 counts isn't too bad, really. 3 volts, 2 counts down. 5 volts. So top of the range is actually really good. It's bang on. But when I go to 6, it's going to change to ranges. It's going to go to the probably 50 volt range, is it? 500 volt range. Oh, there we go, 50 volt. Takes a little while to figure out what it's going to do there. But 1 count down. Let's do 10 volts and only 1 count down again. So that's actually okay. Now my calibrating can do 1000 volts. So we'll be checking this thing out on all the other ranges in more detail. But preliminarily, that looks okay. That's actually not too bad. Right, let's check out the capacitance functions. Now I've got 3 of my standard capacitors here. I've also got another one here. This is a 200 picofarad cap. This one here is 1 nanofarad. That's 20 nanofarad. And this is 1 microfarad. So we can plug this in directly. So if you go to capacitance mode. I'm not going to relative it. It's saying 0, so we should be good. Let's try 200 first. Plug it straight into the front. Yeah, nothing. Didn't recognise 200 picofarad. So 50 nanofarad is the smallest range. Nah. So it's not registering that low level. So 200 picofarad is not showing up at all. Let's go to 1 nanofarad, which I would expect to show up. There we go. 1 nanofarad showing up. 3 counts high. That's not too bad. Let's go to the next one. So this is 20 nanofarad. Just 2 counts down, which is okay. Maybe 3 counts. Certainly acceptable. Let's do 1 microfarad. And on 1 microfarad, we're getting about 3 counts down as well. So it's actually not too bad. Where it does read capacitance, it does quite well. I'm just quite surprised that it couldn't register this one. Let's put a smaller one in. Let's see if it can register. So 1 nanofarad. I think it's 200 picofarad, right? So it should actually register. Put it across here, it should go up. It has. So I can actually see that 200 picofarad. You can see it, but not when it's plugged straight into the front panel. Just does not show up at all. It's being zeroed out. So yeah, that's a bit of a fail. But what I can see does work quite well. So this has this record function. I suppose I should quickly look at that. Actually, it's plugging a measurement. I mean, it's like it will work on everything. So we've got the push record mode, but still in capacitance mode. And we're seeing a reading. It's got manual and auto. So if I just do manual, what does that do? Save this measurement. Okay, so it will store them manually, so you can store the values and information there. Okay, so let's do a save. There we go. It saves it there, number one. Let's plug into next capacitor. Give it a chance to settle down and sort itself out. Do another save. There we go. It saved it. So that's actually quite a handy little feature. Now I'll get a bit closer, you can see it slightly better. Yeah, that's actually quite nice. If you want to record a whole bunch of values instead of trying to remember them or write them down, you could just do that. That's pretty awesome, actually. I like that. That's pretty cool. Well, that's that bit done. So what we should do is go and check this out on my calibrator on AC volts, check currents out, because I can check AC and DC voltage, AC and DC current, and resistance modes on my calibrator. So we'll check the frequency out first on a source I've got over here. We'll see how good that actually is on frequency and see what its upper limit is. It's supposed to be 60 megahertz upper. We'll see how we go with that. And then we'll go to the calibrator and we'll check all these other modes out, like DC voltage, AC and DC current, and resistance mode. We'll check those on the calibrator and see how good it actually is on a calibrator. So I've got this hooked up to a arbitrary waveform generator, and I'm generating 10 Hz right now. As you can see, it's actually reading bang on 10 Hz, which is fine. Let's go down a bit lower. So 2 Hz, that's reading fine, and that's actually quite good to read that low. 1 Hz. 1 Hz, I don't know how you want to pronounce that. But it's doing 1. I mean, it's got decimal places here, so can it go much lower than that? Let's go half of a hertz. So 500 millihertz. It's barely there. It's coming and going. So yeah, below 1 Hz is probably a bit marginal. 1 Hz seems to be really the bottom end. So okay, let's keep going up. So it's back to 10 Hz. Give it a chance to settle. Here we go, 100 Hz. It's only a few counts down there. 500 Hz, which should be top of that range. Assuming it's got ranges, I'm not sure if it does or not. Not on frequency. It doesn't indicate a range, so I don't know if it's got one or not. It's only 2 counts down at 500 Hz. So 1 kilohertz. 2 counts down. 10 kilohertz. Still a few counts down. 50. Couple of counts down. Alright, 100. Yeah, 100 kilohertz is just a few counts down. It seems to be consistent. 500 kilohertz. And we are seeing a duty cycle here too, although it's not quite right, I think. I'm only injecting 1 volt RMS into this unit right now. That may matter when we go to higher frequencies, we'll see. 1 megahertz. So yep, it's a few counts down still. 5 megahertz. Couple of counts down. 10 megahertz. Couple of counts down. Okay, 50 megahertz. Couple of counts down. 60, which is where the top end's supposed to be. Can't do it. Okay, let's drop it down slightly. Do 59. Keep dropping it down till it finds it. 55. No, it's too fast for it. Well, we get in there. That's 53 megahertz. It's almost reading 53. Can't quite read it. So let's change the level. Increase this level very slightly. Changing level will actually help these things. So increase it to 1.5 volts RMS and we can now read 53 megahertz. So let's go 2 volts RMS and we'll go up again, 55 megahertz. Yep. 60. Can do it. 65. Nah, can't do 65. So 60 megahertz is listed as being the maximum frequency it can do. It is 63, 62. So I'm scrolling up and down by megahertz right now. So 63 megahertz, 64 megahertz. Yeah, that's basically it. That's reasonable though. That's actually right. It's just been a couple of counts out the entire time, which is a bit of a shame, but it's not bad, it's consistent. So one test you want to do before I go to the calibrator over there is power this down and see if it remembers the last state it was in. So we're currently on frequency mode. So let's power it down. And then give it a couple of seconds, we'll power it back up again. What happens? Back to DC volts. So in this current situation it's not remembering the last power state. I don't think we had a way of saving that. Default. It goes back to default. Yeah, I don't think there was actually a way of changing that power state. So it went back to the last few settings. Which is a shame because having that is a convenient feature. Anyway, that's okay. So I wanted to check for that. So here we are over at the calibrator. Let's power this thing up and actually have a look. See how we're going. So I'm going to do DC volts first. Put it to its paces on that and we'll see how we go. We'll do 100 microvolts first. And we'll see how this shows up. Nothing there. Let's do millivolts. One count down. Maybe two counts. Okay. 1 millivolt, which we looked at before. Couple of counts down. 10 millivolts. A few counts up. 100 millivolts. One count up. Go to voltage. So voltage, we say we're a couple of counts down there. That's what we saw before. So 1 volt is a couple of counts down. 10 volts is one count down. .100 volts is one count up. Then I'll change to higher voltages. Start 300. So 300 volts. Just a few counts up. 500, which is the top of this range. 7 counts up. 600 is the next range up. And I'm getting exactly 600, which is good. 800 is one count up. 100, one count up. And my 1000 volts is perfect. Cool. Let's check AC. So let's change to AC volts. Do millivolts first. Outputting 1 millivolt AC right now at 1 kilohertz. Can't see that. I might try 100 hertz, see if we can see that. No, it can't. Okay. So 10 millivolts. These lower voltages on AC, quite a lot of the meters that I actually review at these very low millivolt levels on AC, it's quite confident to have trouble reading them. 10 millivolts, to me that's acceptable, really, on AC. Do 1 kilohertz, see if we can still see it. We can, but the accuracy's changed very slightly there. Let's try 10 kilohertz. You can't see that, that's fine. 3 kilohertz is down 10%. So yeah, that's out by quite a bit there. 3 kilohertz. But normally 1 kilohertz is the most you'd expect out of a meter. A lot of meters only go to 1 kilohertz. Some will go higher, but this is only a very low level, don't forget. When I go to a higher voltage, it might be better anyway. So let's get it down to 100 hertz. Let's do 100 millivolts, and that's absolutely fine. So I'll do that same test again, 1 kilohertz. Yep, it's down a few percent. So 3 kilohertz again, which is what we found before, was cutting out quite a bit. Yeah, that's dropping down quite a bit there. What we can actually do is go lower as well. So let's go down to say 50 hertz, which is a quite likely thing to be measuring. That's absolutely fine. Now sometimes meters cannot actually measure the very low frequencies. They have a filter, like a DC filter in them. When you get down to these low frequencies, they can sometimes stop reading. So 10 hertz, that's reading that. That's absolutely fine. No problem there. So let's do voltage range. Do the same test without any changes. Yeah, 10 hertz, you can see it. Back up to 100 hertz. That's the frequency I like to use. No problem at all with that one. That's good. 1 volt. That's fine. Can't complain about that. 10 volts. Took a little while to get there, but it did get there. And it's reading bang on. That's really fine. So it's now at 10 volts. That's a really good voltage to check for. Let's do these frequencies again. 1 kilohertz. Does take a little while to get there. And it's dropped down very slightly there, but it's still pretty good. Let's do 3 kilohertz, which I think is where it's cutting out too much there. It's doing better at the higher voltage. So it's 4 kilohertz. Can it see it? It's waiting for it to update. It can. But yeah, sort of. That's really at the top end where you want to be trying to measure anyway. So that's fine. Get down to 100 hertz. Okay, that's looking really good actually. Let's do 100 volts. The 100 volts AC, 100 hertz. A couple of counts down, that's fine. So 300 volts, a couple of counts up. Let's do 500 because that should be at the top of that range. There's a few counts out there, 7 counts down. Let's go 600. So this is 750 volt range. 600's 12 counts down. 700 is 12 counts up. So 750, which is supposed to be the maximum. 15 counts up. 800. You can read 800. 850. Overload, there we go. So it does register overload. So it looks like it actually allows for 800 volts, not 750. 820. Where's that limit come in? 825. So 825 volts is the voltage overload. Right, I'm just going to do current measurements now. I've changed the leads over. We can now measure microamps and milliamps on that particular port. I have to be careful not to overcurrent it. Very easy to do that if you're not paying attention. So it's got a 500 microamp range, which is nice. So I'm doing DC amps on the calibrator. I'll set it to 0, output on. Should see 0 still. We'll do 100 microamps. There we go, 4 counts up, that's not too bad. So let's do 1 milliamp. 1 count down, that's pretty good. 10 milliamps. Yep, that's bang on. 100 milliamps. So 100 milliamps is also pretty good, it's 1 count out. So I've got to be careful now because if I go up too high I'm going to pop in the fuse. So that's alright. Let's change to the amps range. Will it do anything there? No, it won't. It's definitely dedicated to that particular port, which is fine. So if you're not getting your current reading, make sure you're actually reading the correct function for the correct port. So it's increased this to a higher level. Carefully. So this is 300 milliamps. So it's 300 milliamps, 6 counts high. 500 milliamps, which I think is the maximum. Yep, 5 milliamps, 10 counts high. Okay, let's chop this down, pop a fuse. Down we go there. And we'll change the connections around. Okay, so I'm now on the amps jack instead. Outputting 0. Let's see what we get. There we go, getting a few counts high there. 100 is only a few counts high. 1 amp is 5 counts high. And the highest I can go on here is 1.9 amps. And that's 7 counts high. Okay, we'll do the same thing with AC. Right, I've gone back to this jack over here. We're on an AC configuration. I've changed this to AC amps by pushing this button and gone to milliamps. So I've set to do 1 milliamp. There we go. 1 milliamp, absolutely fine. 1 count down. That's actually pretty good. So 10 milliamps. 10 milliamps is 5 counts down. 100 milliamps, 3 counts down. Okay, that's alright. 300 milliamps. Yeah, okay, it's 15 counts down. 400 is 20 counts down. And 500 is 35 counts down. And don't forget sort of 100 hertz as well. Okay, let's change ports so we can do the higher current stuff. I'm now set up for AC amps on that port. Do 1 milliamp, can't see it. Not unsurprising, it's quite common that's the case. 10 milliamps, can't see it. This is a 5 amp range as well. 100 milliamps. Yep, that's looking really good actually. 1 count out. 1 amp is a few counts down there. And all right to the top. 1.9 amps is 7 counts down. So yeah, I mean that's not too bad. It's certainly close enough for hobbyist use, certainly. Right, let's do resistance now. I've changed the leads around. Let's set up for resistance. I'm not going to use relative mode. I'm going to leave it as is. I'm not going to do any relative measurements, although I could do. This is zeroed. We're getting 45. We're getting 0.45 ohms down here. So that 0.55 ohms is basically lead resistance and contact resistance. So let's plug a short in here. You'll probably see that goes right down. Yeah, it does. So that's fine. If I put a short right there, as you can probably see just here, there's a little short plug there. That drops it right down. So that reading I'm getting here, that's quite normal. I see that all the time when I'm doing these kinds of things. See, 10 ohms. 10.5, so that's within tolerance there, easily. Don't forget we're getting that lead resistance in here as well, which is showing up. When we get to the higher resistances, that'll just disappear. So 100.42 ohms, and we're getting 100.5, again same thing. A slight resistance to the leads. It's the only problem with not having a full wire resistance measurement. You get these errors that creep in. 2 wire resistance is quite common to have errors in it. Anyway, so 1 kilo ohm, reading slightly high there, but that's not surprising because that's still lead resistance showing up. 10 kilo ohms, there we go. We're starting to get down where the lead resistance doesn't matter anymore. Now we're getting rounding errors. So rounding up from this number would be correct. So that's actually reading basically correct now. 10k, 100k, this should be exact now, and it is. Couple of counts. It's not too bad. 1 mega ohm. It's going to give some time to settle down because that's what these kind of resistances need. Need a bit of settling time once you change over. Everything has to equalise a little bit because it all matters. So 1 mega ohms reading a few counts high. That's pretty much stable there now. It's almost there. Good enough for this. 10 mega ohm. The 10 mega ohm is actually out by quite a bit. And 100 mega ohm, I don't think you can read it. No, can't do 100 mega ohm. So there you go. There's that bit done. Let's pull the thing apart. Let's open this thing up and have a look, see what's inside it. So there's 3 screws on the top. I'm guessing there's also some hidden screws by these feet. Oh look, yes there is. Let's push in. There they are. Sweet. Oh, that doesn't go in there. Oh, no, not quite. I need a different screwdriver for that one. These aren't metal threaded screws, they're just standard self-tapping screws going into the plastic casings. Let's get a different screwdriver to go into these other ones. All the same screw, looks like. And don't forget we had this thing plugged into power, so there could be voltages still inside the unit. High voltages because it's mains powered, so there could still be 340 volts DC on the power supply in this thing. So that's a nice little assembly, isn't it? Look at that. This has actually got ventilation holes in there, you can see those holes. There's actually holes through there for ventilation. Yep. There's the power supply, don't touch it. There's the USB port connections. Okay, well this power supply, like I said, there's high voltage potential on here. Where the AC comes in through these connections, they'll be getting switched. One of these capacitors here, it's the Aishi brand, 105 degree rated, that's nice. One of those would be high voltage. So that's a 50 volt cap there. That is a 400 volt cap there. So yeah, that's where the high voltage is, just here. And it's just got a plus and minus marking on here, and some other connections here as well. So we've got 5 wires, 2 are marked plus and minus, which look like power supply, one would be common ground, and the others are USB connections. And there's the back of the screen, and it's got a stacked up board assembly. Let's take this top board off. So we'll look, see what's behind this board. So at least you've got some ceramic fuses in there, which is nice. They're Discman fuses, not Busman, they're Discman. Look, Discman. So you've got 3 screws around the jacks, which is quite nice. There we go, that lifts off now. Careful of the flex, just flip it over. And there's the brains of it all. Let's unplug this connector. So separate it out, get it a bit easier to move. So this is obviously all the analog side of the board just over here. So there's anything you need to see on there, hopefully you can see it. See the part numbers, things like that. So that's a AMS1117, that's a voltage regulator. I think that's a 3.3 volt regulator. I'm sure that is actually, maybe some MOSFET of some kind. Interesting. A relay there, probably some kind of ACC right here. So there's a close view of the back of the board. We've got isolation here, isolation slot, that's nice. Can't see where that chip there is. As far as protection goes, well, there's isolation slots, that's all quite nice. Designed in April 22. It's PTC there. Don't see any MOVs, but that's a big current shunt there. That R12, that's a current shunt, measures the current. Let's look at the digital side. So we've got a little battery here, maybe a backup battery of some kind, which is surprising considering it doesn't actually remember the states, so maybe it's only for the RTC because it's got a clock built into it. Obviously there's a flex after display there, so this is going to be display driver and main processor probably. There's probably some stuff on the back too, quite likely in fact. It's got a header there for programming, what have you. That looks nice enough. Let's put it back together. One thing I'm not liking, because I've got to put another screw back in over here. Do you see how it's really close to that trace there, and it's actually affected that trace very slightly? See, it's stretched up. So when you put that screw in there, it's actually digging into that trace. That's not great. I mean, it is insulated, but it's not going to touch anything. It's not really a big deal, but it is damaging that trace in the process. Not ideal. Does it matter? Probably not, but it could do. It's just a bit of a design oversight, but they didn't actually put a clearance for that trace. I mean, there's all this space over there. They could have shifted over everything very slightly and given clearance for that screw. I also just overlooked it. The other thing they can actually do is put a fibre washer on a screw, and that means it's actually insulated from the trace and actually gives it a bit of a cushion and stops it from digging in. Yeah, bit of an oversight there. Another thing I noticed as well on here, as I'm putting it back together, this is the high current fuse here, right? It's this path, that track is the high current path, right? Because that's at potentially 10 amps coming through here. And they've got the solder mask pulled back here, so you can actually put on more solder to help beef the track up, and therefore not get as hot and maybe potentially stop it from fusing this instead of fusing that. But they've pulled this back, which is fine, but they haven't actually put any more solder on it. It's actually, if I put my finger across there, it's actually below the surface of the solder mask. So instead of beefing up this piece here with some extra solder to make that thicker, they haven't actually done that. It's a bit surprising. And on this power supply over here, I just noticed the actual ratings on here, it's cutting upside down, you can't really see it, but output 5 volts at 2 amps. That's what the power supply is rated for. It's nice. At least you know what voltage it is. 5 volts. Maybe you could actually run this thing off USB instead of off power. I wonder, because that's a USB port over here. I wonder if that's possible. I don't know if you plug a USB port into it. But then, you got the risk of tying your measurements to the USB port. In fact, thinking about it, I should actually check for that to see if the USB port is isolated from the connections on the front panel. Because that's something you need to know if you actually are going to plug this into a USB port. Whether or not you could potentially be connecting your computer via the USB port to a voltage source, for example. You know, if you're plugging this into mains to do tests on it, is it going to link the mains to your USB port? Because that would give you a pretty bad day if it did. And that's pretty straightforward for me to measure too, so I shall do that in a second, once I've re-assembled it all. So what I'm going to do is going to hook up to the earth pin on the power jack on the back. Check on the shield of the USB port. Yep, so the USB port is indeed earthed correctly. Now we actually have connections inside here for various things. Let's check these. Data lines are fine. Fine. And the 0 volts is also earthed. Okay, so the power connection on here is actually earthed, the 0 volt one. That may matter to you. Let's go back onto the port again, on the back. On the earth pin, check inside the connections on the front. Nothing there. Nothing there. I don't expect there to be, but you never quite know. There we go, it's all fine. So there's no connections from the connections on the front to the earth. So these are kind of floating, and the negative from the USB is earthed. Let me just check another thing. Let's go onto the phase and neutral. There shouldn't be anything through here. Yep, nothing there. And on the other one, just to be absolutely 100% sure that there's nothing there. That's right. All isolated. All good. Yep, no problems at all. Happy with that. So there you go. If you like that, don't forget to click like and subscribe. especially if you're new here. Like I said, I do lots of reviews and electronic repairs, things like that, so that might interest you. This thing actually seems fine. I mean, I'm actually thinking it's not bad little meter. I mean, it certainly did better than its specs. The specs led me to believe that it wouldn't be very accurate. At least at this point in time, they actually seem okay. That may change over time when things age and things like that. They may drift out of spec a little bit because of that. Possible. I mean, that's what usually happens with meters when they've got references and things like that. If you're doing, a bit of hobbyist work and you're just getting into electronics and trying to learn things, this actually wouldn't be a bad little one to get started with, because it does all the main features, all the things you're likely to use, and its accuracy is certainly good enough for doing hobbyist work. And it's got some useful features like the record function. That's quite useful. I quite like it actually, and for me to say that, it's quite surprising. To be honest, I wasn't expecting much from it, and it actually does okay. Its build quality is nice. It looks like it's a quality construction. The only thing I don't like is the fact that you try and push a button, it's going to push it over. You're going to have to hold it if you're pushing buttons. It would have been nice if it removed the last power state, so whatever settings you were on the previous time you used it, it would go back to that. That's a bit of a more advanced feature, but I think it's fine. So don't forget to check out the links down below to go to Banggood to check out this thing and find out more information or buy one. And thanks a lot, Banggood, again for sending me to me at no cost. Catch you later.